This is Bob Capetta, and this lesson is on measures of central tendency. So in this lesson, we're going to look at the mean, the median, the mode, and the mid-range. We're going to start with the mean. You probably call that the average. So your standard notion of an average is add up everything you have and divide by the total number of items you have. So the mean is the arithmetic average. So for a quick review, if a student takes 5 exams in a course, we want to find the mean exam grade. So 72, 84, 78, 76, and 90. How do you find the average? Add them all up. So our notation is the mean is the sum of those x values divided by n. What is our n? 1, 2, 3, 4, 5. So adding those up, 72 plus 84 plus 78 plus 76 plus 90 divided by 5. 400 divided by 5, or 80. So the average, the mean exam grade, is 80. But the mean isn't our only measure of central tendency. That's why we're going to look at some others in this lesson. But before we move on, let's look at how we find an average if we are given a frequency table. So we're going to go back and look at the number of credit hours currently being studied for a group of 40 university students. So 4 students are taking 12 credit hours, 2 students are taking 13, 5 students are taking 14 credit hours, etc. So how do we construct the average? How do we find the mean? We want the mean credit hours. Now we could write down 12 4 times, write down 13 twice, write down 14 5 times, write down 15 11 times, write down 16 3 times, 17 twice, 18 twice, 19 once, add them all up, and then divide by 40. But that's not terribly efficient. We have another rule here that we can use. The mean in this symbol is x bar, x with a line over it, is the sum of the x times f, the number times the frequency, divided by the total n. Now, how do we find that? Well, x times f. X is number of credit hours, f is the frequency. So 12 times 4 is 48, 13 times 2 is 26, 14 times 5 is 70, etc. So we'll add up this whole column. That will give us the sum of the xf, but what is the n? What's the total number of students, or the total number of items in this set? 4 plus 2 is 6, plus 5 is 11, plus 11 is 22, 3, 25, 26, 27, 28, 29, 30. The n is the sum of the f's. So in a sense, you can think sum of the xf divided by the sum of the f's. So sum of our f is 30, as we just added up. Sum of the xf, adding up all those, is 446. So the average is simply going to be 446 divided by 30. Now you'll notice I used a spreadsheet to help with that computation. Certainly not a bad idea. So our average, our mean, is 446 divided by 30, or about 14.867, just a little bit shy of 15. So the mean is by far the most important measure of central tendency. That's the one we use most often, but it's not the only one. We also have the median, and I'll show you the formal definition that appears in a textbook. But the idea is the median is the number in the middle. So you organize the numbers from lowest to highest, or highest to lowest. The number that is exactly in the middle is the median. So if there's an odd number of items, you will have a single number in the middle. If you have an even number of items, you'll have 2 numbers in the middle. You've got to take their average. So you take the mean of the 2 middle numbers if that's the case. So we'll look at both circumstances, an odd number and an even number of items for us to look at. So here we have the ages of the Miami Heat NBA team as of January 1st, 2020. So there are 15 players on the roster, 23, 26, 25, 29, etc. We want to find the median age, but the first thing we have to do is put them in order from lowest to highest. Not necessarily an easy task, right? But it's something you've got to do with 15 numbers that's manageable. And the lowest number we have here is 20. The highest number we have is 36. So once they're arranged from lowest to highest, we can ask ourselves, what is in the middle? Well, there are 15 numbers. And one shortcut rule you can use is you take that n of 15, add 1 to get 16, then divide by 2. The 8th one is in the middle. But it's probably easy just to think about it. If I've got 15, 7 below 8, 7 above 8. So 8 is in the middle. So you've got to find your middle number. So in this situation, our eighth number, the eighth age in order from lowest to highest is 28. So 28 is our median age. Again, how do you get 8? Number in the middle. The other way, n plus 1 over 2. 15 plus 1 over 2. 16 over 2 is 8. Is another way to get 8. But 8 is not the median. The eighth age is the median. The median is 28. So here's another list. These are a list of salaries for opening day roster of the Miami Marlins, again, 2020. As I am recording this lecture, the Major League Baseball season hasn't started yet due to the pandemic, but let's hope that starts soon. So we have a total of 26 players who were on the opening day roster for the Miami Marlins. You'll notice I pulled this from a website that actually has them already in order, so that makes our life a little bit easier. Now, what was our idea? How do we find the number in the middle? Well, there's 26. So it's an even number, so there is no actual number that is in the middle. But 13 and 14 are the two numbers in the middle. So if you do your n plus 1 over 2, 26 plus 1 is 27, 27 over 2 is 13 and a half. So if you get a number like that, you take the average of the 13th and the 14th to get to 13 and a half. So to find the median, that's what I have to do. The 13th number is 615,000. The 14th number is 604,200. Or switch them if you want to think lowest to highest. So indeed, in order, no middle number. The two middle numbers indeed are again 615,000, 604,200. So we take the average of those first. The two middle numbers take their average, add them together, divide by 2, and we get a median score of 609,600. So the median is the number that is in the middle. If it's an odd number of items, it's easy to find. If it's an even number, you've got to take the average of the two numbers that bracket the middle. Okay, our next concept, which is a simpler one, is the mid-range. And the mid-range is just the average of the lowest and highest numbers in a data set. So if we go back to our NBA players, the lowest age was 20, the highest age was 36. So the mid-range is the average. Add 20 plus 36, divide by 2 to get a mid-range of 28. So halfway between the lowest and the highest is the mid-range. If we look at the Major League Baseball players and their salaries, we can find the mid-range by, again, taking the highest and lowest. Highest here, 8.2 million, lowest, 563,500. Add them together and divide by 2, that's our mid-range. And we get 4,381,750. Mid-range not used that often, but it is another way you can describe the elements in a data set. Okay, our last idea is the notion of the mode. That's what occurs most often. So which item has the highest frequency? Now, you can have a tie. You could have 2 or 3 items, or possibly more, that all have the same frequency, in which case you have multiple modes. Or you may have no data value that occurs more than once. If no data value occurs more than once, then you really can't say you have a mode. So here is our credit hour data set. Which number occurred most often? Well, 15 hours occurred 11 times. So that's your mode. That occurred far more than anything else. So in that situation, we say that 15 is the mode. Looking at the Major League Baseball salaries, what do we have? Well, 8.2 million is there once, 8 million is there once. 595,000 is there twice. 580,000 is there twice. But the actual minimum number, 563,500, probably the minimum in the league, is there 4 times. So the fact that 563,500 is there 4 times, that makes that the mode. That appears more often than anything else. And the last example I'm going to look at are the ages of the NBA players. So which age occurs most often? Well, let's see. 23 occurs twice. 29 occurs twice. 30 occurs twice. Nothing occurs 3 times. So In this situation, we have more than one mode. In fact, all three of those things are modes. So our conclusion will be 23, 29, and 30 are all modes. And that will conclude this lesson.